Hi, this is Omer Razan, and this video is for Data620 Assignment 5. For this assignment, there are multiple questions that needs to be answered. The question one is choose a corpus of the interest. So for this project, I'm decided to use Project Gutenberg. That is a site which allows you to read a book directly from HTML file, and data also can be found here. We can see that here. This data that I'm using for the project file. The idea that I got that to use this file is basically when I search for the text data, I had a chance to look at the project Gutenberg, and then basically I looked at the book search and then look at the most popular books, and then from here I get the HTML file of books, and then this is how I got the best the most downloaded data. Um, the first thing that I'm doing for this project is basically I'm loading our packages that needs to be done in order to finish this assignment 5. And when we look at here, so basically I'm typing the path, and then I'm defining this one as a raw data. As we can see that here, this data actually has different chapters or letters. I wanted to make sure that I start with the chapter 1, and I ended it with this. The sentences basically, I'm defining where it started and then where it ended, the text, the portion. So when we look at here, I can see that the raw data, I'm defining in where it started and then where it ended here. And then what I'm doing is basically I'm using a tokenize and taking that raw and putting a tokenize right here. So in order to define how many unique, the second questions that we're having is basically how many total unique words are in corpus. For that reason, what I'm doing is basically taking that tokenized data, and then the first basically looking at the alphanumeric words, and the second one is basically looking at the lower cases. And then when I look at it here, I'm seeing that we have 6,613 unique words. So as a sample, I'm just displaying right here top the 10 the words here. You can see that there are letters in there. So basically there's a I, there's a P here, there's an A here. Um, the the unique words includes a letter which needs to be excluded from the data. So I will estimate the length of each of the unique variables. So for that reason, so basically I'm taking that unique words, and then I'm putting a data frame that I can have the words and the length right here. So we can see that right here, their total, the chapter length is 7, P is a 1, M is a 2, and then looking at each word's length. So by doing that, because I want to eliminate the one that has only one letter here, so it's going to be cleaning. So what I'm saying here is basically from the data frame to basically give me that words that has a length of 1, so that you can see that there are a lot of lengths of that, and I'm only looking at the top portion of that right here. And second thing is basically having a clean data frame. I'm calling that df words clean, and just taking the the length of the greater than 1. So you can see that we're actually not having any letter inside it. So every word is length is greater than 1 right here. So by looking at here, before the cleaning, we can see that there's 72,226 words in it, and after the cleaning, I'm having 66,456 words in it, because the reason is because I'm only taking the the words length that greater than 1. Um, So third question is taking the most common words, how many unique words represent half of the total words in the corpus? So for that reason, what I'm doing is basically taking the one that unique words, and I'm looking at the freaking distribution, and then I can see that right here that the top rank it is basically the and off and two, and then the higher one is value is 3,928. And then when you look at the half of the unique words, it's actually um, 33,229 words. The next thing that I'm doing is basically just putting the all whole words. So that we created a data frame from that unique words. I'm defining the columns of words, and then what I'm doing is basically having the all words and just having the value counts. When you value count, I'm just trying to look at what is the frequency of that word that's seen that text. So by just looking at it, I can see that right here, top down. The first one, it's a 3,928, and next one is and then so on and so forth. It comes to right here. And the next, I'm gonna find the most common words that present half of the total words in the corpus. So basically, I need to calculate. I need to have uh, cumulative sum of this frequency. So for that reason, I do have a frequency. All I need to do is basically look at the cumulative sum of that variable, and then you can see that here. And then frequency is defined here, and then it's changing here, and then you can see the frequencies and how many con frequency uh, uh, is available here. And the next thing that I'm doing is basically how many words present half of the total unique word. So basically we do have a unique word, and then I'm taking the length of that and then divided by 2 here. And so basically I do have a count frequency. I'm taking it from the data. I'm taking only that count frequency column from that letter, and then I'm looking at the length of that, and then we can see that here basically 74 words presents the half of the total unique words in the corpus. For question 4, so we're asked to identify the highest 200 frequency words in the corpus. So I'm going to look at the unique words with the highest frequency and review the top 200 most common words. So the way I did it for question 3 is basically looking at the distribution, the frequency distribution. I'm only taking in 200 right here. So you can see that the it's 3,928, and then n is 2,807, and so on and so forth. It moves on right here, and then we can see it here, top 200. And the next question is that create a graph that shows the relative frequency of these 200 words. So since I do have this data frequency distribution that I created right here, so it takes takes the unique word and then looks at the frequency distribution. All I need to do is basically just plot that variable, that's object there. So the relative frequency of the top 200 variable can be seen here like this, but unfortunately, I can see that this is the and off, but it's really hard to see each variable, and um, so this is how the relative frequency of top 200 variable looks like. When we look at the question 6, basically, does the observed relative frequency of this word follow the Zipf's law and explain. So the Zipf's law states that given a large sample of words used, frequency of any word is inversely proportional to its rank in the frequency table. So the word number n has a frequency proportional to 1 over n. That means the word frequency has inverse relationship to the rank in its frequency distribution. For example, fourth most common word. When we look at here, the fourth most common word has a count of 1,642. Um, should occur 50 times as frequent as 200 most common word. So when we look at here, so 200 most common word rank as the value is the 37. So it should be, the grade should be occurred 50 times as frequent as the 200's most common word, which is a 37 right here. But when we do 37 times, because this is the fourth rank, and then this is the 200 one. So basically 50 times. So I need to have this number is 37 times 50, which is 1,850, which is kind of relatively. So in my course, basically, I see partially this law plays some role, but not exactly. Um, so question 7, in what ways do you think the frequency of the words in corpus different from all words in corpora? So um, for that question, I will review another corpus and find out the freaking word of corpus and the difference of the frequency of the word from the all word in corpora. So for that reason, I'm gonna use the root text corpus. So for more information about the root text corpus can be found here. So when we look at here, this is the main um, the website that NLTK actually .org actually has it. When we look at it here, I'm using this ones, and then there are a couple of different ones. There's a brown corpus one, and then the one that I'm using is basically root text corpus. So that's what I'm using. I just picked this one, um, and then when I look at this, basically, I want to compare with the one that I have it. So I'm looking at the categories this routers has it, and then you can see that the categories are available right here. So all I'm going to do is basically pick one category from here. So for that reason, I'm picking the coffee. The coffee is available here, so you can see that coffee is available. I'm going to do exactly the same process that I do to answer the questions from the 1 to the 6. So basically, I'm going to take the coffee category, and then I'm going to look at the alphanumeric ones, and then I'm going to look at the lowercase, and then define what's the unit word words, and then put that into the data frame, and then I'm going to look at the length of that word because I want to eliminate that any letters that are in there, and then I want to print out to what's the length of before the cleaning unique word is basically you can see it right here the 30,656, and then after the cleaning, so defining that any length that is less than 1, just exclude that, and then after the cleaning I'm having 26,568. And what I'm doing is basically it's the same thing that I did it for question 4, and then looking at the freaking distribution of unit words. And then when I do that, basically I'm looking at the most common 200 variables. When I have it, you can see that right here. The is 1,710 and 2 10,005 and so on and so forth. But it's a common thing that I do have exactly the same the same variable but different counts for my corpuses as well. And also we can see that here I do have an and the second one is here 2 actually, but and also has a different counts. And lately I'm showing how the this words clean looks like. Here we can see that how all the words look like it. Thank you.